Hey everyone, hope you're doing well. Today we are going to be going over the last lesson of the unit and also the last lesson of the semester. All right, so this will be the last video lesson of this semester. All right, and it's very similar to what we did before. All right, it's very similar to the triangle congruence proofs. In fact, we're going to be doing triangle congruence proofs, and then we're going to be adding just one little step at the very end. That's it, okay? So things to know. So suppose you're given the statement, dog is congruent to cat, right? From that statement, all right, we can write 6 other statements that can be concluded from it, right? The first thing that we can do is we can match up all the angles. So dog is congruent to cat, which means that angle D is congruent to angle C, right? That also means angle O is congruent to angle A. And finally, it means that angle G is congruent to angle T. All right, so those are all things that we know. We also can say some things about the sides. All right, we know the sides are congruent as well. We know DO is congruent to CA. We know OG is congruent to AT. And we know that DG is congruent to CT. Okay, so those are the 6 things that we know, and we call this property, all right, we call it CPT, oh wait, no, I'm already forgetting what it is, CPCTC. All right, now, what does that mean? Okay, I'm going to write out what it stands for. You don't need to ever know what it stands for. We're always just going to write CPCTC. But it stands for congruent parts of congruent triangles. You ready for this? We're almost done. Are congruent. Now that's really long, all right? You're never gonna have to write that all out. We're always just gonna write CPCTC, but you do need to know CPCTC. All right, so this is important to know. Let's highlight it here so that your eyes go to it whenever you go back to these notes. All right, congruent parts of congruent triangles are congruent. So what we're gonna do with that, all right? We're going to do some proofs, but the final goal of the proof is not to prove triangles are congruent. It's to prove one of the pieces are congruent. And in order to prove that piece is congruent, first you have to prove the whole triangle is congruent and then add another step. All right, so here's what that looks like. So the first thing that you have to do is we got to figure out how do we prove these 2 triangles are congruent, okay? So we have some stuff given to us, all right? We know that angle L is congruent to angle Y. And we know that LAP is congruent to YAP. So both of those are marked. Those are our givens. Now, what else do we know? Well, the triangles are stacked up against each other, which means they share a side, right? So we know that AP is going to be congruent to AP. Right? And that's the reflexive property, as they said. So now we have our 3 things, right? We have, if you look here, we have an angle, and a side. So we want to look here. So we know that that's our side right there. So we've got angle. Is the side in between the 2 angles? No, right? That's not the side we have. This is the side we have. So the side's not in between the 2 angles. It's angle, side. So we know our triangles are congruent by angle, side. And now that we've proven the triangles are congruent, we can say any piece of it is congruent that we want. And so this is where you got to look at the prove, all right? We're trying to prove PL is congruent to PY, and the reasoning for that will always be those 5 letters, CPCTC, all right? Congruent parts of congruent triangles are congruent. But you just need to remember that this is the last thing you use after you've already proven the triangles are congruent. So let's do another one, all right? For this one, all we're given is that I is the midpoint of ST and I is the midpoint of RH, okay? So, reasons given, all right? Now, because I is the midpoint of those two things, now we know some stuff, right? Now we know that IS is congruent to IT, and we also know that HI is congruent to RI. And we know both of those because of the definition of midpoint, right? Now, what else do we know? Well, we've got those two angles right there, right? And I think that's given for us. Yeah, SIH is congruent to TIR, and that would be vertical angles. Okay? And now we can say the triangles are congruent. Now, we're not given the triangle statement up here, right? So you're going to have to do that on your own. All right, so what do we want to call them? Let's call them SIH. That was the first one. And then we can match it up. So S matches with T. So if we said SIH, we'll say TIR. Okay, and that's by SAS as they give us. But we can look and see. Okay, we have two sides, one angle, side, right? Okay, now what? So this is kind of a weird proof. We're trying to prove these lines are parallel. Lame proof. All right. Angle S is congruent to angle T. How would we know that? We would know that by CPCTC, right? That's what we use right after we say the triangles are congruent. We can say any part we want is congruent by CPCTC, okay? Now, because we've said angle S is congruent to angle T, now how can we say the lines are parallel? Well, all right, let's look here for a second. All right, I'm going to get a different color. Look at the two lines. That was a horrible line, by the way. All right, remember, parallel lines are always going to be meaning that we're talking about the same thing. We're talking about alternate interior angles, right? But this time we're actually going the opposite of what we normally do. Normally we know they're parallel, so then we say alternate interior angles are congruent. But if you remember, we can actually switch that around as well. If alternate interior angles are congruent, then the lines are parallel, and that's by the AIA converse. Okay. So that would be how this problem works out. This is kind of a weird one. We did this together for a reason. I wouldn't put one on a test where I made you prove lines are parallel. All right. All the ones on your own, you're just using CPCTC like normal. You don't have that extra step on the end. But I want you guys to try 3, 4, and 5 on your own. Okay. See if you can do it. We can go over them together if you want. Bring questions to class. That's always good. But yeah, hopefully this made sense to you guys. It's just normal proofs and then one extra step at the end. And that's it. So let me know if you have any questions. Other than that, have a great day.